Alright, in section C, we're going to be taking a look at what is called arithmetic sequences. There's many different sequences that are out there, but the two that we will be studying primarily in this chapter will be arithmetic sequences and geometric sequences. So let's first take a look at what is called arithmetic sequences. What is an arithmetic sequence? This is what it is by definition. Okay? And that's basically what it is. It's a sequence defined by a common difference between any two successive terms. Let's take a look at that example again that we had from section A and B. It started off with 36, 31, 26, 21, and onwards. Now, if we go ahead and take a look and the difference between any two successive terms. So say for example we take these two terms here, then the difference between those two terms would of course be minus 5. That is, if I take this term minus that term. If I do any other two successive terms, say for example 31 and 26, if I take this term minus that term, again it is going to be negative 5. And notice that it continues in that pattern for all the terms of the sequence. Therefore, what we say is that this sequence is an arithmetic sequence. Now, what we're going to do is we're also going to go ahead and introduce some notation that you would use to formally define an arithmetic sequence using very specific mathematical notation. This is how you would write it using that mathematical notation. So notice we said that if we have any sequence, this sequence is arithmetic if and only if u sub n plus 1 minus u sub n is going to be equal to d for all n being a positive integer. Okay? So notice that what we said here, remember, we talked about the sequence using this notation here. And we're going to say that if we take any two consecutive terms and we take the previous term and subtract it from the subsequent term, we're going to come out with a value called d. So in this sense over here, I took the 31 minus the 36. I took the 26 minus the 31. That came up with a common d value of negative 5 for this example. Now notice, it doesn't say 36 minus 31, 31 minus 26, because of course, therefore, then you would be coming out with a different value of d, which would be incorrect. So be careful that you're always taking the subsequent term minus the previous term before it. Okay? And of course, being that n is going to be a positive integer, the reason for that, of course, is because this is the first term, that's when n is equal to 1, second term, third term, fourth term, etc. Okay, so what I would like to do also is notice that this is very specific mathematical language. We need to include a bit more sophisticated mathematical notation. So you see this if and only if? This is the way that you note it. You can either write IFF, which is if and only if, or you can use this symbol, okay, which means that we go this way and that way. So if this is true, then that is true. If this is true, then that is true. Okay? Now, what we're also going to do is we're going to introduce some more notation here so that we can make this a little easier to write and more mathematical. So for all n is actually written this way. For all n being a positive integer, instead of writing all of that, all we have to do is write this. Okay? And that's how we would go ahead and define what an arithmetic sequence is. Now, how do we actually go ahead and determine what the arithmetic sequence actually is? So remember before, in the previous section, you were given the sequence, you needed to find the terms. Say, for example, if you're given the terms, how do you find the sequence? Okay, so let's go ahead and take a look at that. Now, if you know for a fact that the sequence is indeed arithmetic, then what we know is we can always come out with a d value. So the d value in this case is going to be 31 minus 36, and again, I could have taken any two subsequent terms of the sequence to find this common difference, and we know it to be -5. Now, the formula that you want to use is this. Any arithmetic sequence is always going to be described as u sub n is going to be equal to u sub 1 plus n minus 1 times it by d. That is always going to be your formula for an arithmetic sequence. Okay, so let's go ahead and take a look at how we actually generate that u sub n as a formula for this particular sequence. We already know that d is going to be equal to -5. So all we really need to do now is just substitute the values that we need in order to solve for u sub n. So here we go. We know that u sub n is going to be equal to u sub 1, and remember u sub 1 refers to the first term of the sequence. That will be 36. Plus n minus 1 times it by d, and of course we found out that d was going to be -5, and that is going to be common between all of the successive terms. So there you go. U sub n is then going to be equal to 36 minus 5n plus 5, and if we simplify this, u sub n is going to be equal to 41 minus 5n. Okay. And if you remember from section B, I actually used this formula. So if we use that formula, we can go ahead and generate all of these values. And in addition to that, of course, we can generate any particular term value that we want. And that's basically what it is to have an arithmetic sequence and to come out with the formula for the sequence itself.